Hello everyone, welcome back to Everything Swift. Today we'll be tackling Leetcode question 814 titled Binary Tree Pruning. In this question, we are given a root parameter here of type tree node that is actually representing the binary tree. And our task for today is basically to remove any subtree in this given binary tree that doesn't have the value of 1. So basically, as we can see here, it's quite explanatory. Given the root of a binary tree, which is this parameter here, return the same tree where every subtree of the given tree not containing 1 has been removed. Right. So basically, any subtree that doesn't have the value of 1, the node doesn't have value 1, we are supposed to prune it. Right. So I think this example one is quite easy to understand what it's trying to do, but I think the second example is actually uh, quite good uh, in terms to help us understand the question basically. So as we can see here, we're given the root of value 1, and then it has a left child and right child, and the left child here is value 0, and its child left and right also are 0. But on the right side of this root here, we have a subtree of value 1 for this road, for this node, sorry, and then the left child is value 0 and the right child is value 1. And then the output is basically 1, 1, 1. Basically, it has pruned this entire subtree here and this particular subtree. So I just wanted to bring to your attention combining example 1 and 2. One thing we have to note is we are not actually removing the node that is value 0. So in example 1, we can see where although this node is 0, we do not remove this whole entire chunk of subtree here because this root node here, its right child is actually 1, but the left child is 0. Therefore, we only remove the one that is 0, and the one that has 1, we have to keep it. That's why this particular entire subtree here, this chunk here, we only remove the left child, right? We don't remove this particular root as well, although it is value 0. So that's an important thing to note. As for this example here, we can see this left child of this node here, we have 0, and every node inside the child of this node left and right is basically 0 as well. So in this example here, this whole chunk here is suitable to be removed. As for this part here, the right child here, we can see there is 1 1 and 1 0. So 1 obviously is not a candidate to be removed, so we're going to keep this, but the child here is 0 and it doesn't have any other child, so this is the last node, right? So, and its value 0, that's why we are pruning it, right? So the condition here is basically like, first we need to know whether it has subsequent child for every node. Once we identify that it has, we have to continue checking whether the child has further childs or is the last node. And if it is, what is the value of the nodes? If it's 0, then we go ahead and remove it, right? So that's basically the task we have to do today, and the strategy we're going to use here is basically called post-order traversal. So there's like three main types of traversing a tree, where it's pre-order, in order, and post-order. So basically post-order, what it means is we are going to traverse everything on the left and then followed by the right side. Only then we traverse the route itself. So that's the meaning of post-order traversal. Feel free to check it out because it's quite common strategy to be used for three question, in order, post order, and pre-order traversal. Those are the three things. But for this question here, we're going to do a post order traversal. So okay, so let's jump straight into the code and see how we're going to use post order traversal, and keep in mind the two conditions that we're supposed to do to solve this question, which is to check whether each node is it the leaf node, which is it doesn't have any more child, and we are supposed to also check the value of the node whether it's 0 or 1, right? So if it fulfills the two requirement where the node is 0 and it doesn't have any child, then we can go ahead and remove it. If it has, then we continue traversing it, right? So the answer is actually pretty simple once we identify what we're supposed to do. So if you guys have watched my previous video, you guys know I like to check immediately the parameter, since this is optional, whether it is nil or not, right? If it's nil, then basically there's nothing to be done, so we go ahead and return nil. But in this scenario, this is also useful because we're actually going to recursively call this prune tree function here. And the first thing I'm going to do is make this roots as a variable, because can't really manipulate it. And then what we're going to do here is, as I said, we're going to use post order traversal. So what we're going to do is, I'm just going to force unwrap it here because we already checked if it's nil, so it's quite safe to do it. Root.left equals to prune tree dot root dot left, right? We're traversing all towards the left, and once that is done, we are traversing all towards the right. So it's the same thing. We're going to call this particular function again and recurse towards the right side, right, left and right, right? So now once all of this is done, right, we are actually going to get to the root node. So at every root node, what we're going to check is if the root.val is equals to 0. Just remember the two condition again. If it's equals to 0 and the root of left equals to nil, and root dot right equals to nil, then basically we know this is the leaf node and the value is also 0, right? So we can go ahead and just return nil here. Otherwise, it means that the root value could be either 1 or it still has children inside it. So we cannot prune this particular node, right? So we have to go ahead and return the root. And yeah, that's about it. So this if statement here, this conditional check is checking the two statement that I made, the two conditions, whether it's the value of the node is 0 or it has any further children, right? So this is the post order traversal format, left, right, and then we're going to go back to the root. And yeah, I think that's about it. Looks fine to me. I'm gonna run this code and see whether if it works. There we go, first attempt, looks good. Let's try and submit this. And there we have it. That is the solution here. So just to recap, we use post order traversal. We check for every node whether it is value 0 and if it has any other children. And if it fulfills the requirement, that two condition, we can just set it to nil. Basically, this is our pruning of the tree. So yeah, that's about it. I think it's pretty short answer for this question. So I hope you guys find this video helpful. If you do, please feel free to subscribe to my channel. I'll be posting more videos from here on now. Thank you and bye bye.